All right, we're back to section 4.3, 4.4. Getting ready to do the examples. Directions are find the intervals of increase and decrease, find the local extrema, find the intervals of concavity, find all inflection points. And here are the functions. Let's do the first example. Example 1. Let's remember that the first derivative will give us information on increasing, decreasing, and local extrema. Second derivative, concave up, concave down, inflection points. So we're looking at the first function as a polynomial, and we're going to analyze the first derivative. So that's what I wrote, first derivative. Take the derivative. You can do that. 4x cubed minus 12x squared. Set it equal to 0. And I factored out 4x squared. Set x squared equal to 0 and x minus 3. Just set the ones with the factors with the variables equal to 0. And you get x squared equals 0 and x minus 3 equals 0. Square root, you get x equals 0 and x equals 3. Those are your critical values. Now, what I want you to do is put those critical values on a derivative number line. All right, now what do I mean by that? I need to cover this up because I've given all the information here. So what we're going to do is make a number line like this. And this is just the way I do it. I make a little number line, and I call that number line f prime. We're going to be doing an f double prime number line, so make sure you label it, and I put the derivative right there. And this is where the derivative is 0, and we're going to test in between to see if the derivative is positive or negative. So I'm going to test points on 3 intervals. Those 3 intervals are this one from negative infinity to 0, 0 to 3, 3 to infinity. So I'm looking at negative infinity to 0. I just pick anything. I picked x equal negative 1, substituted in the derivative, whichever one, and I got negative 16, which means it's less than 0, and that's negative. And then I test a point from 0 to 3. So I tested x equal 1. When I did that, I got negative 8, and that's less than 0. Then the last one, something from 3 to infinity. I picked 4 most likely. Yep. So f prime of 4. And I'm putting it into not that one exactly, but I'm putting it into this derivative up here when we took the derivative straight here, 4x cubed minus 12x squared. So you'll see that's what I'm plugging in. I got 64, and that's positive. So I'm getting negative, negative, positive, and that's what I put on here. Negative, negative, positive. In this interval, the derivative was negative, then this one was negative, this is positive, so that means decreasing, decreasing, increasing. Now there's a change of sign here. That means that the function goes from decreasing to increasing, and that gives us a local, what is that? That's a low point, a local min. So we write that conclusion right here. After all of these, you should write a conclusion answering the question. F is increasing on the interval from 3 to infinity. F is decreasing on negative infinity to 0 and 0 to 3. So I'm just pulling them off of here, right? Decreasing, negative infinity to 0 here. And then I use a union from 0 to 3. And we've got increasing from 3 to infinity here. And f has a local minimum at 3, negative 27. And I got that negative 27. This is all about f now. Your conclusion is all about f. And all I did was plug 3 into f, which is the original function way back when. Put it in there. As a matter of fact, I think I did it down here. Nope, I didn't. And I got negative 27. So there you go. That is the first derivative. I'll come back with the second derivative.